So it gives me great pleasure to introduce our first speaker of the evening. Dr. Michael McTavish is a postdoctoral research fellow working with the Smith Forest Health Lab at the University of Toronto. His ongoing research examines the implications of ecological novelty and invasion for restoration, the ecology of non-native earthworms, including the recent jumping worm invasion, and biological control of weeds, including introduced Phragmites and garlic mustard. Please welcome Dr. Michael McTavish speaking on jumping worms.
Great. Thank you very much for that.
I'll hand the floor over to you, Michael. You can share anytime now. Thank you.
Perfect. Thank you very much. Okay, just bringing that up and make sure that's coming through all right. Okay. So good evening, everyone. Very happy to be joining you for this Earth Day celebration. As has been introduced, we're going to be chatting a little bit about jumping worms. So a little bit of a hopefully not excessively depressing topic, but we do have some actionable items and things that you can look for and do at home as a part of this to lend a hand. And sort of discussing this as what we like to call kind of the second wave of earthworm invasion effectively. So I want to start things off with a little bit of just general earthworm invasion background, because this is a part of a broader story. Most of the earthworms that we have in Canada are non-native and up to this point primarily European species. And this isn't a process that is isolated to North America. This is a part of a global invasion process with non-native earthworms spreading with increasing globalization across every continent of the world except for Antarctica. So we did have native earthworms in Canada, but the vast majority of these were wiped out by the last glaciation, as they don't generally do well under large quantities of ice. So what we've seen after that glacial retreat has been a gradual recolonization and invasion of those now earthworm-free soils. As with so many invasions, earthworm invasion is very much a human-assisted process. Their ability to move around on their own is fairly limited and fairly slow. So the long distance dispersal and the rapid dispersal that we see is largely caused by or driven by us. So various vectors that we tend to see for both earthworms and their cocoons, which you can see pictured there as these fairly nondescript, just little particles that are very easy to miss in soil or mulch. These materials can be moved around intentionally or unintentionally through things like ship ballast, horticultural materials, people dumping bait in the woods, any kind of road work or movement of soils, and even by things like cocoons getting trapped in the treads of vehicle tires or shoes. To give you an idea of how this process can sort of play out, if we have some sort of hypothetical population of earthworms with a reasonable density, that can of course become a source for other new populations. So if you have spread by any number of these mechanisms that we've already identified, you get these very small little sort of founder populations that can pop up, and then those can, of course, over time, sorry, not sure why that changed there. Lost control of the slide advancement for a quick sec, sorry. There we go, got it back, sorry about that. So those can grow over time into larger populations as well. And then those, of course, can become sources for further spread. So it can become a bit of a positive feedback cycle going there. So I want to introduce now, of course, our star for this portion this evening, jumping worms, what we sort of refer to as the second wave of invasion. What we've been talking about for the most part up to this point has been this so-called first wave of invasion. So this is the movement of largely European earthworms from that area into North America. And this has been going on since the early 1500s to 1600s, so moving with early European colonization, and is still ongoing to this day. So as we have material continuing to move into North America, we still have more European earthworms coming in. More recently, we also have what we are referring to as the second wave of invasion as well. This is the movement of species primarily from Asia now, which is much more recent. So we have estimates that suggest maybe sort of mid-20th century, some earlier, some later. And this is growing and becoming sort of more of a prominent and immediate issue. So both are happening simultaneously now. I'm going to be referring to jumping worms throughout broadly, but it's important to remember that what we're actually talking about is a collection of somewhat similar species. So in the US right now, there are 16 documented species of what we call ferritomoid or jumping earthworms. These are from 12 different genera that are native to East and Southeast Asia. They have many different common names, and these are often quite regional, so they'll be called different things in different areas. Jumping worms is probably one of the most common, and it's what we'll use, but you'll also hear them referred to as things like snake worms or crazy worms or other sort of fun names also. So just remember that this is actually a collection of multiple species. A reasonable question would be, well, is a worm just a worm? And in this case, it's not. So jumping worms do differ from European earthworms in a number of different ways. Unlike European earthworms that can be distributed well throughout the soil column, jumping worms tend to be fairly close to the surface, so they're shallow burrowing. They tend to be parthenogenetic, which means that they can reproduce asexually, so a very small number of worms can form a new population. They also have an annual life cycle, which is a bit unusual. A lot of our European worms will live for multiple years, but our jumping worms actually just live as an annual. So the cocoons will overwinter in the soil, they hatch out into juvenile worms in the spring, grow up, mature, reproduce, and then die. And then those cocoons will be in the ground until the following year. All of these different traits essentially sum together to give us a species that can be very rapid invaders that have dramatic impacts on the soils, how they're structured, and as a result also how they function. One of the reasons that we're interested in talking about earthworms as invasive species is that they have been recognized as important sort of architects of the soil, or what we might call an ecosystem engineer, since the time of Charles Darwin. Darwin actually wrote his last book on worms as a subject, and it's a pretty fun read if you're looking for something to pick up. Earthworms are these so-called ecosystem engineers because they substantially modify the habitats that they live in. By changing those habitats, this can alter the survival and growth of individual plants. Some species tend to do better when worms are there, and some species can do worse. The net result of all these changes is that we can have changes in overall vegetation, community, composition, and function. So once an ecosystem has been invaded, we can see a dramatic shift in the types of plants that are there, and as a result, sort of how that functions as an ecosystem. One of the main things that is driving this is the propensity of jumping worms to convert organic matter that they're eating and topsoil that they're burrowing in into a layer of these loose, crumbly casts or castings. And that's basically sort of just terms for worm poop. And you can see that highlighted in this image here. We're going to revisit this later when we talk a little bit about identification. But it's essentially just sort of converting that top organic matter into just a layer of worm poop. And when we take that and we extrapolate that across a whole invaded area, we have a photo here from Toronto ravine where you can see just large areas of what was a forest floor basically converted to a desert of these organic castings with very sparse vegetation mixed in with it. That conversion of the litter layer and the topsoil into this worm casting has a variety of primarily detrimental impacts on vegetation that's trying to grow there. And this would apply in a garden just as it would in a forest. So this tends to produce, it exposes the soil surface by removing the litter layer that would protect it. That means that soil and vegetation can dry out. It can be very vulnerable to browsing from things like deer. It's very susceptible to erosion, and that erosion can carry away loss of nutrients. So all things that tend to be bad for plant growth. One of the interesting reasons that jumping worms tend to have stronger negative effects compared to our European earthworms would be that when European earthworms are occurring at, when they're very large, they tend to occur at low density. So we can think of things like our night crawlers or our dew worms. On the other hand, when they are occurring at very high numbers, these tend to be very small species. Jumping worms kind of break this pattern by becoming very large-bodied and typically occur at high density, and that combination means that they can have very strong impacts. And I just want to quickly hold up for a second and check, because it seems like some folks are having issues with slides or audio, and we've got some annotations that are being added as well. I just wanted to check if everything was okay here before we plow forward. Kelly, or
Yes, we've had a couple of individuals indicate that they are not able to hear, but I am not experiencing any issues hearing you, and I would ask people not to use annotation and to please keep your cameras off. Okay, thank you very much.
okay, not a problem. Just wanted to double check there. I don't think I can get rid of the annotations that are there already, so we might just have to live with that artwork for the time being, and that's okay. So we'll carry on and look at jumping worms in Ontario specifically. So we're going to focus it regionally a little bit more here. To give us a bit of a timeline on how this sort of process has gone, the actually very first documentations of jumping worms that we have in North America go all the way back to the 1860s, and this was in California. There is some question about the taxonomy of what we're actually looking at, so these records are sort of something to be looked at with caution. The very first Canadian documentation occurred quite recently in 2014. These were collections made near Windsor by noted earthworm taxonomist John Reynolds. These were then, everything was sort of quiet until summer of 2021. At this time, we were doing some work on some of our biocontrol projects, and we were informed that actually gardening communities were observing earthworms with some unusual traits, worms that they hadn't seen previously. And so we got involved in that project and were able to confirm, unfortunately, that there had been multiple sightings of jumping worms in southern Ontario in 2021. Once we knew that we were there, people started looking, and that following fall, we got the first Atlantic observations in New Brunswick and Nova Scotia as well. So as of the present day, we have 31 confirmed records of jumping worms in Ontario. And this is according to EDMAPS, which is the main platform that we've been using to track this. And we'll talk about this a little bit later. So we have a fairly coarse level, county level breakdown of that here. I'd like to pull out a few observations from this. The first would be that we still have activity around that original Windsor area where we got that 2014 sighting. So they are still in the area. We have an unsurprising cluster of activity around the GTA, Hamilton, and the Tri-Cities. And then right now we have a northern extent reaching up to Georgian Bay. You'll note that we have a lot of the areas just even right here in southern Ontario that aren't really filled in. And it's important to note here that absence of proof does not equal proof of absence. So this doesn't mean that there aren't jumping worms there. It just means we haven't documented that yet. So really a more accurate way to depict this map would be to think of this as just, we don't know, and we don't know until we check. And that's why this sort of community awareness and monitoring of this invasion, while it's still new, is really important. Again, as a reminder, we're talking about jumping worms, but in Ontario, we've documented 5 distinct species so far, so fewer than they have in the US, but that number will likely grow over time. And if we look at the information that's coming in with these records, we see that most of these observations are currently coming from gardens. People are finding them in their gardens while they're working or putting new material in. Although we also see some observations from trails and parks, more natural areas nearby, which is concerning. And then some oddball observations from grass yards, directly in a potted plant, and even in an enclosed terrarium as well. So that distribution is all quite large scale. Sometimes we're interested in also what's going on at a finer scale as well. So we had a fourth-year honors thesis student in forestry, Esther Tang, who was working with me on a survey of several ravines in Toronto. We had found jumping worms in one of the ravines, and we were interested in how common they were overall. So she did a survey that fall looking at 11 different ravines, and at the end of the work had identified jumping worms in 4 out of the 11, so about a third. This was kind of a mixed good news, bad news situation for us, in that it meant they weren't in all the ravines, but it wasn't just a one-off that we were seeing. They are definitely here. which was a little bit sobering. Within those sites, though, we also see quite a bit of variation. So at these sites, Esther would walk the main trail of the ravine and at fixed intervals would sample for jumping worms. So this is a map of one of those sites. The black dots are where nothing was found, and then yellow would be where jumping worms were observed. And we can see this is a site with very low occupancy, and we also had some that were very, very high. So this site had about 94% of the sample plots filled in. So basically completely occupied by jumping worms. This was a little startling to see and also suggested to us that this didn't just happen. We're only observing it for the first time now, but they've almost certainly been there for at least a few years without us noticing it in order to get to that kind of level of spread that we're seeing. So to summarize some of that distribution kind of general background information, what do we know at this point? Just a couple of years into tracking this new invasion. We know that jumping worms are present at multiple locations in Ontario. We know that we're looking at least 5 species. It's probably a relatively recent invasion because we're not seeing it everywhere like European worms, but it is also probably not brand new. We're seeing that they're abundant in gardens, but can also spread into nearby natural areas, which is concerning. And at various scales, we see that they are not yet ubiquitous, but they're also not rare. So that leaves the very important question of what do we, and what do you, if you're interested, do now? The first part, and this is a really important point, although it can be a little bit of a bitter pill to swallow, it is a really important thing to realize, which is that non-native worms, including jumping worms, will and are already becoming inevitable and growing parts of the Canadian soil community. This isn't the kind of invasion that you come back from. They're here and they're here to stay. And there are a variety of reasons for why that is the case. The big one, of course, is we don't have practical control options. We'll talk about that later. They're below ground. Many species are nocturnal. The cocoons are really difficult to detect, especially if you're talking about screening incoming horticultural materials or soils. Really hard to catch everything. There are so many different ways that they can move around. And sadly, there's also insufficient direct, immediate economic incentive to do anything about this from a regulatory standpoint. So they're here to stay, and they're going to become more common. But that doesn't mean we should do nothing about it. What we should do, in my opinion, after many years of working on this, really depends on which group we're talking about, because these are different cases. So if we look at the European earthworms, this is an invasion that's been ongoing for hundreds and hundreds of years. They are abundant, they are widespread, we can't do anything about them, and there is a good ecological argument that at some point they are in this process of naturalizing. They are becoming a part of these ecosystems after all this time. And that sort of leads us to this idea of basically learning to live with them. And this is a fascinating topic that we could do a completely separate talk about of how do you actually do that. Fortunately, most of us are already pretty good about thinking about worms as something that we want to see as a part of a healthy soil that's good for a garden. So that part's pretty easy. For jumping worms, however, it is admittedly a different situation. This is a relatively recent invasion, as best we can tell. They're not yet widespread. We don't have control options, but we do have ways that we can try and slow the spread. So my recommendation for what to do is a 2-step process. First, we learn where they are. And second, we try and slow the spread as best we can. So learning where they are, knowing what to look for, and reporting jumping worm sightings. This is a 3-step process that I've pulled out of some of our community science outreach monitoring program that is designed to learn how to identify jumping worms, go out and search relevant areas in your neighborhood or plant material that you have, and then if you are finding anything, report observations online. So the first part is that you need to know how to search for and identify jumping worms from other types of worms. And this, generally what you're going to see first is not actually the worms, but alterations to the habitat. So we've already seen some of that cast material. It can be very, very distinctive, and that's the first thing you're usually going to notice. If you see that, that can then lead you to the worms themselves, and you can gauge whether they are jumping worms or non-jumping worms based on the combination of how they behave and also their morphology, what their body looks like, different features that they have on them. So starting with that habitat alteration, this is the piece you're actually looking for as you're walking along a trail or looking into a pot of material. As we said, jumping worms convert organic matter and topsoil into these casts, and these casts have a very distinctive appearance and texture, especially when they're dry. They get loose, they're crumbly. You can pass your hands through it very much like a kind of dried coffee ground or dried out ground beef or TVP kind of texture. There are certain habitats where they're more or less likely. So casts are often found in wet or shaded areas where they're not going to dry out as quickly. So beside tree trunks, on the backside of a log, underneath a pot or a tile, underneath newspaper that's been left on the ground, that sort of thing. Moist environments is where you're more likely to find this. These casts tend to be spread fairly evenly across large patches of ground, especially if it's a larger invasion. So it's got this kind of continuous carpet cover that we can see here. Other non-jumping worms do produce casts at the surface. Some species do, but they tend to be clumped into little discrete piles. So I've highlighted and outlined those on the left here. You can see there's space between them. These little piles are what we call middens. You would see that from a dew worm or nightcrawler. But jumping worms, their casts tend to be spread out over the ground. Those casts can be very shallow if it's a recent or small invasion, but if it's larger or older, it can be up to several centimeters deep. So this is an area where we've just hollowed out basically a big pit of just loose, crumbly cast material. So we'll see if it works for us. I've included a video here so you can see this is an area where it looks like soil, but it's actually all cast material. So as you just pass your hands through it or kick it with a boot, you can see it's very loose, very crumbly. You can already have a sense of how that's not going to support plant material very well, but that's, I'd say, on the extreme range of what we tend to see. Once you have identified an area where you think they are, you can move some of those casts aside, and now you're looking for the worms themselves, and you want to be able to tell, is this a jumping worm or is it not? Fortunately, they have some fairly characteristic behaviors which help in this identification. Where they get their name from is that they jump or thrash side to side when disturbed. It's a way that they try and get away from predators. So we've got another video here, and you can see you can just unearth some of that cast material, and they're often quite shallow. They're quite close to the surface. So if you find a worm, you pick it up, you get this kind of thrashing avoidance behavior. They don't do it all the time. You see that one sort of calm down there at the end, but that is very diagnostic of jumping worms, and again, where they get their name from. We've got another example of that here. So you can see they can be a little bit hard to pick up and keep a hold of because of that thrashing. But if they're doing that, you know you've got a jumping worm. This is an example, a video taken from staff at the Royal Botanical Gardens, just to give you an idea of how high that density of worms can be, and how close they can be to the surface. So you're going to see someone just kick through some of that litter material and uncover a whole bunch of jumping worms here. So right under the surface, and doing a little bit of that thrashing, though less than they would if you actually picked them up. Another behavior that they have, another way to avoid predation, is that some jumping worms will self-amputate their tail. So if disturbed, they will drop the sort of back part of their body to try and throw off would-be predators, also very diagnostic. And once you have them in hand, in addition to that behavior, they do look physically distinct from other European earthworms. So we have a comparison here between a jumping worm and a European nightcrawler earthworm. And you can see, compared to the European worm, the jumping worms tend to have a body that's fairly smooth and shiny. It's almost got a metallic kind of sheen to it. They tend to have more of a gray or gray-brown color in contrast to a red-brown. And adults will have this reproductive structure called a clitellum. It tends to be milky white. And if you were to flip the worm over, you would see that it runs in a full ring all the way around the body, and it's quite close to the head. On a European worm, it sits just on the top, so it doesn't go around the bottom, so it sits more like a saddle over the part of the worm. But do note that that feature will be absent from juvenile earthworms. You only see it on adults, but it is a really useful clue of what you're looking at. It's also important to know what to expect at different times of the year. So we looked at this already when we mentioned that they have this annual life cycle. So if you're to go during the late fall or the winter, or even now in the early spring, there's not really much to see. So in most places, they'll be as cocoons in the soil dormant. There may be some old casts from a previous year, but it's not the best time to actually see that activity. Once they hatch into juveniles in spring and early summer, they are present. They're going to be smaller, and the changes to the soil are going to be less pronounced. It's as you get into the summer and then the early to mid fall that they start to mature, and the cumulative impacts on the soil are most obvious. So this is actually the best time, I would say, sort of fall, August, September, October, to go looking for jumping worms. So once you know what to look for, as you now all do, you can search your local area or gardens or material for jumping worms, or just be aware of it. So we invite people to, for example, search a local area, and this can just be while you're taking a walk in a garden, park, or trail, or inspect horticultural material that you may be bringing into a garden for jumping worms. As we said, what you want to do is first look for that habitat alteration, so look for casts. If you see casts, then you can start looking for worms, and you're trying to identify them based on a combination of behavior. Do they thrash? Do they drop their tails? And morphology, all those features that we outlined. If you find what you think is a jumping worm, then it comes time to report it. For that, we need photos and videos, ideally showing that thrashing behavior, because that is so diagnostic. And then those can be uploaded to the EdMaps platform, and a video can be sent, and we'll get to that here. So this is that reporting observations online. This is an incredibly important part of the process, because it is very useful to folks like us to have access to the information, to know what's out there, to take advantage of the knowledge and enthusiasm that gardeners and community members have for all of this, so that we can know where this invasion is actually going. The platform that we've been using is EdMaps, and there's the URL there. We're using this instead of iNaturalist just because it offers a little bit more of the data that we actually need and sort of want to be able to collect. So one thing that you can do, for example, is there's an additional comments section where if you are reporting an observation, it's really useful to us to have any supplemental details that you might have, like when you first noticed them, did you see them years before and just didn't know what you were looking at? Or was this the first time? Do you have any suspicions about where they may have came from, plants or soil amendments that were added in recently, that kind of thing. Unfortunately, you can not add video. You can add photos, but not video to EdMaps. So usually what happens is when an observation is reported, it needs to be verified. That gets forwarded to me. And at that point, we usually ask for a video if you have one. And if everything checks out, we can say, yep, this is a jumping worm, or no, it isn't. And then it gets logged accordingly. So the second step of the process is, so we want to know where they are, but we also want to slow the spread and really try and mitigate that invasion into new habitats. Even though we can't prevent this, it's really valuable and important to slow the spread, because this reduces cumulative stresses on ecosystems. Our ecosystems are already dealing with a lot, and if we can slow this down, it gives them more time to adapt. Plants can develop resistance to this sort of invasion. Novel predators can learn that jumping worms are good to eat, and so on. So buying time is really, really important. So there are three main things that you can do. You can watch for new populations of jumping worms, which we've just gone over. So looking for casts and worms in areas like a garden, natural areas that are nearby, potted plants, any kind of soil amendments. I know this is a piece that everyone is often looking for, and it is possible to manage small, very contained infestations where it is practical to do so. So small scale control can be done by bagging material or tarping materials to solarize infested material. So heat is what you need. An excess of 40 degrees for a period of 3 or more days has been shown to kill off the adults, the juveniles, and the cocoons. And the cocoons are the important, tricky one. And then that material can be safely disposed of. Unfortunately, this really is only practical at small scales. So if you have a pot that you think is infested or a raised bed, For a small area, this can be used. Anything larger, it's just going to become too much effort and not very effective. Individual worms can also be euthanized if needed in alcohol or soapy water to deal with them. You know, if you're noticing them and pulling them out and are trying to control that population. I've seen on the internet and with other discussions all sorts of wild things that people are trying to do. My favorite was someone going around with a blowtorch trying to deal with them that way, in addition to adding all sorts of pretty nasty stuff to the soil that will kill jumping worms, but will also kill everything else. People are working on management tools for jumping worms, but to the best of my knowledge right now, what we're seeing is there's really no scientifically supported, safe, effective best management practices that are suitable for larger scale control. So small scale can be dealt with heat and alcohol and soapy water. Anything larger is kind of beyond our ability to do anything right now. What's really important, more than that control, is to identify and limit spread from known populations. So if we're looking at new plants, for example, there's particularly high risk if they're coming in a soil-based medium, if they're mulch plants where there could be cocoons in the mulch, or if they are tropicals or imported plants. In these cases, inspecting new plants for the signs and symptoms that we looked at and trying to avoid sharing plants out of an infested area would be really important. Mulch, soil, and compost can theoretically hold worms and cocoons as well. So watching out for that, and also ideally preferring materials that have been heat treated. So again, above that 40 degrees. This is still tricky because we know in large mulch piles, jumping worms can avoid the heat and then recolonize the mulch pile. So it's not 100%, but it does help. And finally, because we know cocoons can travel in treads, being careful to clean off footwear or tires of bikes or shoes when moving between areas, especially if you think jumping worms are around. So I'm going to wrap things up here just with a quick recap and some conclusions. Jumping worms are now in Ontario and they are spreading, and they're going to keep spreading. Jumping worms can have dramatic negative impacts on soils and on plant communities. So that goes for both natural environments and also to an extent gardens, although we don't have this particularly well documented or researched. This is definitely something to look at going forward. There are unfortunately no practical large-scale control options, and further invasion is inevitable, just as it was for European earthworms. However, it's still really important, very, very important, to know where they are, to understand how this invasion is happening, which areas they're getting into, which areas have been unaffected, and to slow the spread as much as possible to give our ecosystems and gardens and all these different habitats time to adapt to this new ecosystem engineer. To do this, we ask anyone who's able to contribute to this early detection and monitoring process. So know what to look for, search for jumping worms in areas that you have access to, and report to EDMAPS. And finally, to slow the spread. So watch for whether earthworms or jumping worms are in an area, remove small populations when it's practical to do so, but more importantly, try to limit spread to new areas. If you're looking for more information on this topic, I would recommend you check out the Invasive Species Center. Has a profile on jumping worms with some great information and links to other resources as well. We helped build that, so definitely you should check that out. We also, as a part of our community science monitoring of jumping worms last fall, we put together a webinar with a variety of different partners. This is available as a video recording on the Royal Botanical Garden RBG YouTube page. So the link is there, and you can find that by looking up RBG Jumping Worm Webinar. And you can also feel free to contact me directly if you have any questions about this at the email that is listed here. So this is a relatively new invasion. We're really on the cutting edge of this, and so it's a really important time to be doing this work and to have the participation of gardening communities in particular have really been superstars about caring about this and bringing this information forward. That's how we found out about it in the first place. So we really appreciate the support from these many collaborators and supporters over these last couple of years. So again, I'd like to say thank you very much for the opportunity to join you tonight. My email contact information is here, and I'm happy to take some questions as well.
Thanks, Michael. Kathy, do you have questions in the
Yes.
queue?
I have one question here. So I'm understanding that jumping worms affect forest floors, ravines. They prefer wet, moist areas, or will they become a problem for agriculture and growing food?
So we've certainly found them in fairly dry environments as well. I'd say the wet conditions is more of a microhabitat kind of thing. So within a given area, they're going to favor sort of damper pockets, sort of shady spots and that sort of thing. But they definitely can tolerate drier conditions as well to a point. The agricultural element is really interesting as well. Jumping worms are newer and sort of having these more dramatic impacts, but we've also seen negative impacts from European earthworms in forests as well, but positive impacts in gardens and agricultural fields. Basically, this comes down to the fact that these natural systems and production systems are very, very different. So some of these alterations can actually really be good for crops that are growing quickly, that can take advantage of nutrients that are being mobilized by earthworm decomposition very quickly, whereas in a natural forest that would sort of be lost. So until we see more data to be concerned about it, I think the agricultural risk is probably sort of less of a worry compared to impacts to more natural systems overall.
Is there any cooperation with Asia as to how to control them?
Not to my knowledge. It's this interesting situation where our invasives are their native healthy earthworm fauna, right? So these would be species that you would want to see in your soils, and it's a positive indicator of soil health. So there wouldn't be really local knowledge about how to control or remove this or how they invade and that sort of thing. It would be something that you want. There could be some potential sort of looking at how you can sort of prevent that invasion process and looking at spread, but usually that tends to be more on the recipient's standpoint in terms of whether you're doing any screening or regulations and that kind of thing. And so far we haven't seen any of that, and I would be very surprised if we did, because again, we didn't see anything for European worms either.
What are the natural predators for these worms?
So lots of species from lots of different habitats, so lots of different predators, but the sort of same typical range of birds and small mammals, and even down to invertebrates and amphibians that you would expect for sort of any other kind of earthworm species. As we talked about, jumping worms have a number of tricks up their sleeves to deal with would-be predators, so the thrashing and the tail amputation and all this sort of thing. So anecdotally, what we've seen is that our sort of normal earthworm predators are not exactly sure what to make of them at this point, but there's certainly the potential for them to learn to consume them and like them over time. So, as a reminder, our European earthworms weren't here several hundred years ago either. So all the things that have learned to eat them and make them a normal part of their diet, that was a new food that they learned to eat over time as well. So we would suspect that to kick in over time for jumping worms also.
A lot of people use worm castings as fertilizer in their gardens. Why are jumping worm castings different?
Right. So there's some really interesting mixed data about what earthworms do to overall soil fertility in different systems. The sort of simple version of it tends to be that earthworms are decomposers, so they break down organic matter and they make nutrients available. If there are plants that are able to use those nutrients at the rate that they're being produced, that can be a positive effect. So that's why we see, or part of why we see worms being really good in gardens or in agricultural fields, is that those crops and those plants can take up nutrients, a lot of them, and very quickly. If you have a forest that is used to nutrients being released very, very slowly as things like leaf litter and woody debris break down over many years or decades, that sudden flux of nutrients, they're not able to make use of that. So that either goes towards invasive species, for example, herbaceous species that can take those nutrients up, or can be basically washed away when it rains and leached away and removed from the environment. So it all depends. You're getting nutrients from the cast. The question is someone there to make use of them, or do they become lost?
My garden club is planning to root wash all potted plants before putting them into our plant sale. We deal with hundreds of plants. What is the best way to manage the soil we remove from donated plants?
Yeah, so first of all, I mean, the root washing is a really good step that can be taken as well if groups are interested in doing that. If you have bare roots, the chances that you're accidentally bringing in any worms or cocoons goes down quite dramatically. I know that can be a lot of work, so that sort of comes down to a group by group basis. In terms of the soil that gets washed off, that sort of waste soil, that would be a good candidate if it's a reasonable volume for that kind of bagging and solarization process that we looked at. So putting that in a big hefty black garbage bag, for example, putting it out in the sun, trying to hit temperatures over 40 degrees, keeping them there for 3 or more days, that level of heat should be sufficient to kill off anything that might be in there, and then that can be used or disposed of as you see fit.
Jumping worms protein is a delight for the birds? Question mark.
Yeah, I mean, as we talked about a little bit, I haven't seen any studies on this in Canada yet. I'm sure we will be doing those kind of studies down the line. Anecdotally, birds, you think of classic robins and that sort of thing, they're not quite sure what to make of these guys because they are, so difficult to just kind of grab onto. But I strongly suspect at least some species in time will learn to eat them. I think jumping worm protein is probably as good as European worm protein from a bird standpoint, once they figure out that behavioral side of it.
That's all the questions I have for now, Michael.
Okay, great. Well, if anything else comes to mind, happy to take those, and my contact info was there too if people want to.
Oh, just another one
we
just
got a few
popped
more.
up. Our Hort Society is going to do root washing on site rather than having to deal with potentially contaminated soil.
Yep.
And how are they fighting this in the USA?
Yes, yeah. So I think good idea on that root washing protocol. That sounds like a smart way to deal with that. And then in the US, so they have had jumping worms for longer, so there is a greater time depth of research. Although it's still surprisingly sparse. Thinking about any kind of earthworm as sort of a non-native invasive that's a problem in forests is actually fairly recent. Most of the research goes back to mid 2000s, really. So still in the process. There is some excellent research out there and publicly available information as well, Facebook groups even, and that sort of thing that talk about what people have tried and different vermicide compounds and all that sort of thing. Still, to my eyes, what I've seen is that it's at a very early stage as well, and that's why I kind of say I don't think we have that best management practice recommendation for dealing with this at any kind of practical scale yet. That doesn't mean we couldn't get a tool like that in the future, or something like a biological control agent that's very specific to these particular taxa, but we're just we're not there yet, really.
Okay, I have no more questions.
All right, great. Thank you very much.